Hello and welcome to the Project 1 CAM series. This is part 2, the Toolpaths. My name is Steven Thompson and this is CNC Beginner's Guide. In the last video we went over how to create the setup for Project 1, which is all the kind of initial machining conditions and considerations just to get you ready for creating toolpaths. And now we're going to make all the toolpaths in Fusion for running on a CNC machine. So yeah, there's a lot of details, so why don't we get started. Okay, so this is where we left off in the last video, and we have a completed first setup. So the first thing we need to do is we need to start making toolpaths. We need to figure out which toolpaths we're going to do and in which order to make this thing. And this is a very simple part, so there's not a lot of different things you could do. When we get into more complicated parts, there's going to be a lot more different considerations. But since this is so straightforward, the first thing that we're going to do is we're going to face this. And what I mean by that is we see that there's a little bit of stock material on top of this model, right? So the model is below the top of the stock, and that's on purpose. We didn't want to put it right at the top of the stock because the stock, when you receive the stock, it's not perfect, right? It's like not super flat, and we got some scratches and dings in it, things like that. So usually the first thing you do is you face your material. So you use the tool, use a large face mill to remove the top layer of material. Now you can use a regular end mill, but we're going to use a face mill. But what that does is it establishes kind of starting plane and kind of a nice clean machine surface to get going from. Okay, so let's do that. So to make our first toolpath, it's going to go to 2D. And these are all 2D features, so this is going to be a 2.5D part. So all of our toolpaths are going to come out of here or the drilling section. So let's go to 2D, and there's a facing toolpath right there. So 2D face. Okay, and we have the toolpath dialog box open up here. And there are tabs along the top, and we're going to work our way through the tabs in order to make all the toolpaths for this part, or to set all the settings for this specific toolpath. So there's the tool tab, the multi-axis tab, which we're not going to touch because this is just a 3-axis part, geometry, heights, passes, and linking. And we're not going to make changes in every single one all of the time, depending on like the complexity of the path we're trying to do and the specific details of how we want that path to be executed. We might have to go in and change some specific setting in one of these places. But it's going to be different for every toolpath. So let's just get going with the first one. We're always going to have to select a tool. That's for every toolpath. So let's do that first. So under Tool, I'm going to click Select, and it brings up our tool library here. Now, we created a tool library in an earlier video based on a tool library that's in the book CNC Beginner's Guide. And this is just kind of like a generic reference library that I know works on a Haas VF2. So, if you're not running this specific machine, your settings are going to be a little bit different. But it's kind of a good starting point for whatever we're doing. If you want to use your own tools here, you have to build your own tools from scratch, or you can grab tools from the Fusion library. However you have it set up in your shop or your workspace, wherever you're running CNC machines. But I'm going to use this sample library from the book, CNC Beginner Guide. So I'm going to highlight that library on the left, and then my list of tools in that library comes up, and I get to choose which tool I want to execute this toolpath. I want the 2-inch face mill, so I'm going to click 2-inch face mill there, and click Select. Okay, so there is our tool, and it's showing above our part. And let's work our way through some of these. So multi-axis, not going to change anything there. Geometry, this is where you would specify the geometry, but for a facing toolpath, the kind of default is to just remove all the material from the top surface. So you don't actually need to select a new geometry here. Same thing for the heights tab. All the heights are basically set here. And for the passes tab, this is going to do it in one pass. And I know that the material left on top is 50 thou because I set that in the set when I made the setup. I know that that is a good depth for this tool. So that's going to be okay. I'm going to leave that there. And you don't need to make any of these changes. And then the linking, these are all actually probably okay too. So go ahead and click OK. The facing toolpath is a quite simple toolpath, so I didn't actually need to change very many things on that toolpath. Okay, so here's our first toolpath, and that's what it looks like. The line is where is the movement or the position of the center at the end of the tool, and where it's going to move. The different colors of line mean different things. Yellow means it's a rapid movement, like a positioning movement. Red is like a ramping movement. Green is a transition, like a lead in or a lead out. So it's like getting into a toolpath or getting out of a toolpath. And then blue is the cutting. And these kind of like relate to feed rates mostly. So it's like there's a rapid feed rate, and then there's like a lead in feed rate and a lead out feed rate and a machining feed rate. And the blue line is the feed rate while it's machining. So it's nice to see, you can see it like this, but actually what's really useful is to see a simulation, like a 3D visual simulation of this. And we do that by going to the C simulation. So to get there, right click on setup 1 and go to simulate. Okay, so now there's a few things to learn here. In the simulate dialog box, we have all these different options, but they're kind of grouped into sections. There's a tool section. You specify which part of the tool you can see in the simulation, just the flute or the shaft or the holder, the whole thing. And if you're depending on what you're doing, you may need to kind of block out different parts of it, but we can use the whole thing right now. Toolpath, and that's if you want to see that line. And if you do want to see that line, do you want to see all the lines or just the line for that operation, or whatever it is? I think that just maybe the line for the operation is good for us, but you can change that. There's the stock, so you can see it shows the stock here. If I uncheck that, it removes the visual of the stock, but it's good to have a visual of the stock, I think. And then there's colorization. Now this is the stock's going to change colors as you machine it, and this dictates how it changes colors. So you can see here, comparison is what it's on. Comparison shows, you can see right here, positive material, so it still needs to be machined as blue. Green is you've machined what you need to do, and then negative means you went too far into the material. There's also, you can visualize it with colorization via operation or tool. So a new surface is exposed by a new operation or a new tool will be a different color, and you get these multicolor kind of forms. So depending on what you're kind of looking for in the simulation, you might try and change the this colorization. But I think comparison is good for us for right now. Accuracy is kind of like the accuracy of the simulation, and this doesn't need, I think that you can learn a lot of things from this without having the accuracy really high, and there's very few cases where you would need a very high accuracy in the visual simulation. I only say that because the drawback is that you put it really high and then it's a lot of processing power required by your computer, and it could really slow down your computer and the whole thing. So to kind of like make sure that doesn't happen, I'm keeping that a little bit low. You can check the transparent box, and it makes the stock transparent. It's kind of nice, actually. Regenerate on rewind if you want that. Stop on collision if you want that. You can change the viewpoint relativity as well. There's the info section with like the position of the tool and things like that, but statistics is nice. It gives you a machining time estimate, which will not totally be accurate. You need to like make some, there'll always be like some difference between this and your actual machining time, and it depends on a lot of small and big factors, but it's a good starting point. I've been on machines where it's like you're only off by a couple seconds, and then I've used some machines where it's like the actual machining time is basically twice whatever this estimates right here. So it really kind of varies, but it's, as long as you know how your machine is relative to this number, it can be useful. Okay, so now we need to actually see the simulation, and then we have the playback bar at the bottom here for that. So I can click the play button and it'll play the simulation. Right? I can go back little amounts. I can go back to the beginning of that toolpath, and I can slow it down or speed it up with the slider. If I play it and I slow it down, I can speed it up. If you go past the center point, it goes backwards. But that's good. I could pause it. I can go in, could take a look at what's happening here. You can see that we're actually, machining off a small amount from the top, exposing the top surface. Keep playing it. And even with a relatively low accuracy setting here, I still actually get all the information that I need out of this, really. All right. Okay, so that is pretty good. Yeah, the simulation, we're going to simulate after every toolpath because we're going to make changes to the toolpath based on what we think should happen or we want to happen, but we'll only be really sure of it if we see it in the simulation. Okay, so I'm going to exit the simulation now. And it's time for our next toolpath. So, we can go a lot of different directions here. But I think what would be good would be to clear this area around these, the area around here. So let's do that, and let's do that with an end mill, and let's do it with an adaptive toolpath. So to do that, let's go to 2D adaptive clearing. Now, what adaptive clearing is, I kind of talk about this in more detail in the book, but basically adaptive clearing is a way of machining, a way of creating a toolpath geometry that's based on the amount of tool engagement. And what that means is that when this path is created, it's going to maintain kind of an upper limit on tool engagement, or kind of like keep your tool engaged in the material an optimal amount for as long as possible. And that's going to actually reduce machining time, and it's just a much more efficient way of machining. And you can only do it with CNC machines because you have really finite control over the motion of the machine. What it's effectively trying to do is it's trying to limit the force on the tool, or like the load on the spindle, to like a constant amount. And it does that using geometry, which is actually quite clever. So we can't use the face mill to do adaptive. We can, you might be able to at some point, but we're not going to. It's not. We're going to use an end mill to do it. So I'm going to click select here under tool, and under CNC Beginner Guide, we can let's use a 1/2 inch flat end mill, because we don't really have any geometric constraints on this one. And this is for aluminum. This is the 1/2 inch flat end mill that we created when we created this tool library. Go ahead and click select. Okay, and all of the tool settings are in there already. Now let's go to the geometry section. Now I need to specify the geometry that is going to drive this toolpath. And I want it to be this area right here, but I actually want it to clear not just this area, but the area above this circle, and also the area out beyond the edge of this part, because there's still material there, right? There's still stock material. So if you just select a face, it's just going to limit the machining to where that face actually is. But if you select a line, and in this case, a contour, really, this contour right here is an open contour because it kind of extends outward in all directions. And an open contour will be machined out to the edge of the stock. So if I select that line, it machines everywhere from there out to the edge of the stock material, which is exactly what I want. Okay. Now we'll go to the heights tab. I don't need to change anything in here. But in the passes tab, we are going to make sure stock to leave is checked, because this is a roughing toolpath. Adaptive toolpaths are roughing, so they're going to be, the surface finish is not going to be great because you're being kind of aggressive with the cutting tool. So we'll do a roughing toolpath, and we'll go back and we'll finish that surface, probably with the same tool, but with a different approach, and it'll leave a much better surface finish. The other thing that is really important, very important to figure out here is the optimal load. Now this is the amount of tool engagement while it's doing the adaptive toolpath. And the optimal load value is a tricky one to figure out because it depends on the machine that you're cutting on. It depends on kind of like the material that you're cutting out to, the type of cutting tool that you have. But even if you have two of the same machines, with different work holding, this number might be different. Or if you have two same machines and they're kind of like have different, purposes. One's in a production environment, one's in a prototyping environment. You might have different numbers here. You want a number that is going to be safe, that's going to work, that's not going to be too much for your machine, because this is basically the load that's going to be on the spindle, or it'll correlate with the load that's on the spindle. So a higher number here will mean that your machine has to work harder in order to machine this, and a lower number means that it'll work lower. If it's too small, then the toolpath might take a long time and it might be really inefficient in that way. So kind of depending on your goals, you're going to make a choice that is that corresponds with kind of what your goals are. So what is that value, right? And I have in the book, CNC Beginner's Guide, in the appendix, and the appendix is also on the website, but in the appendix I have a page where I have suggested optimal loads for different materials, and different diameter size tools on a Haas mill VF2. So I know these ones work on this specific machine. If your machine is more capable or more powerful than this, and your tools can handle it, you might get away with a larger optimal load. Or if you have a smaller machine, you might want to select a smaller number than this right now. But it's good to kind of see them all next to each other. So this is a 1/2-inch tool in aluminum. The optimal load in this table is 0.1348. So it's close to that, actually, 0.1348. But it's not a linear relationship, so it's like it's hard to kind of track down. These are all numbers that I tested out on this machine and that I know I've kind of verified on this machine that they work. You're gonna have to do that with your own machine. You'll have to start at some point and then figure out, kind of respond to what's happening on the machine, either increase that number or decrease that number, depending on the results that you're getting. And that's going to be like, that's what it takes to be a good machinist, is to really pay attention in that kind of way. Okay, so I put that number in right here for the optimal load, 0.1348. Okay, we have stock to leave checked, change the optimal load, and I don't think we need to change anything in the linking tab. We'll do that kind of stuff later, but the defaults are good for there, so go ahead and click OK. And we have our first adaptive toolpath. Now we see all this kind of like really interesting movement that's happening here, and the reason it's doing that is it's calculated the path such that the optimal load, and the optimal load is really the kind of distance between these two lines here, right? And so it's maintaining tool engagement to so that while it's machining, it doesn't over engage the material, but can machine in a really efficient way. So let's go ahead and simulate that. I'm gonna right click setup one and simulate. We can start from the beginning. Go ahead and click play. Make it go a little faster. There we go. And there's our adaptive. So see how the tool's remaining engaged for a long period of time, but not over engaged. It never engages more than the optimal load, which was, we set at 0.1348 or whatever it was. Okay, so that's our adaptive toolpath. What we want to do next is we want to clean that up. We see we haven't gotten down to green yet because we left stock on that stock to leave tab. So that's a great way to do a roughing toolpath, but then so get most of your material removed pretty quickly, but then still have a nice surface finish. You have a roughing toolpath, and then right afterwards you have a finishing toolpath. Okay, so let's exit the simulation and let's do that finishing toolpath. And that's going to be a 2D pocket toolpath. But what I like to do is, it's going to be the same tool. It's going to be the same geometry. The only difference is it's going to be a pocket toolpath instead of an adaptive toolpath. And we're going to uncheck that stock to leave tab so it goes all the way to the material. So in that case, what I can actually do is I can do what's called create a derived operation. So I go to this 2D adaptive toolpath, right click it, and say create derived operation, 2D milling, 2D pocket. So it's going to make a 2D pocket toolpath using the same tool, same geometry, same settings. So you can see tool number 2, geometry, same geometry. We didn't change any heights, and the passes. The only thing we have to change here is you have to uncheck stock to leave. Now there's no optimal load in here because this is a pocket toolpath. Optimal loads are only for adaptive toolpaths. And it's the same geometry, it's the same tool, but we'll see how the toolpath is very different. So we see here the driver here for this is maximum step over. And that's going to drive the toolpath geometry. Okay, so go ahead and click OK. You can see that that is the toolpath there to clean it up. And then the 0.3 is the distance between these lines here. I think that the big difference between the pocket and the adaptive is that the the pocket just uses the geometry to be machined and then the step over and then makes that same geometry at different, or like the kind of increasing size. Whereas the adaptive really considers the amount of material that the tool is engaging with. So even though the step over is only 0.3, or the step over is 0.3 here, the tool might be engaging at different amounts, and even more than, it can be engaging with different amounts, and to the level where if you were to try and just do this toolpath first without the adaptive, you might break a tool or something bad might happen. It would definitely be too much tool engagement. Okay, so let's simulate what that looks like. Right click simulate, or right click setup 1 and simulate, and play it. Facing, we have our 2D adaptive. Looks good. And then there's our 2D pocket. Cleaned it up. Nice and easy. Okay. I'm going to turn the toolpath to mode tail. It's kind of nice one. It just shows the tail of the toolpath. But it opens it up visually so you can kind of see more what's going on. Okay. Great. So we have a few more features to machine. We have this pocket on top to machine. We have the hole here and the counter bore and then the perimeter. Okay. So let's exit the simulation. And let's go ahead and machine. Let's machine this pocket up here. But before I do, I need to kind of figure this out. Which tool can actually fit in here, right? So I'm going to click inspect, measure, and that corner radius. Diameter 0.25. Okay, so that means that I'm limited by the tool that can fit in there. I can only fit a 0.25 inch diameter tool in there, a 1/4 inch diameter tool, which is okay. So let's do that. I'm going to close that. And I'm going to do same thing I did with this area out here. I'm going to do a 2D adaptive to rough it out and then a 2D pocket to finish it off. So let's do it. 2D adaptive clearing. Tool is going to be from beginner's library, 1/4 inch flat end mill, and aluminum, and select. The geometry is going to be this inside geometry. I can select that contour at the bottom there. Don't need to change the heights, passes. I'm going to check the stock to leave and leave a little bit of material inside of there for the finishing pass. And that should be okay. Go ahead and click OK. All right, so we have our tool that ramps down in and clear the area. So I'm going to right click setup one and simulate. And let's see. Facing 2D adaptive on the outside. 2D pocket to finish on the outside. And then we have our 1/4 inch tool, which is going in there and doing a 2D adaptive on the inside. All right, so we are left as we were on this outside area with a little bit of material inside of there. We're going to finish that up with a pocket toolpath. So I'm going to exit the simulation. And just like before, it's going to be the same tool, same geometry to pocket clear this area. So I'm going to make a derived operation to save a little time. Right click adaptive 2, create derived operation, 2D milling, 2D pocket. And click, oh yeah, we have to go to the passes tab, right? And uncheck stock to leave. And click OK. Okay, so that looks good, but then I just realized something that we forgot to do. So I'm going to simulate this first. I'm going to skip down to this adaptive. I could just click on it in the browser bar on the left here. Boom. And it jumps to that point in the simulation. Okay. Looks good. And now here's the pocket toolpath. All right, pocket toolpath cleaned it up. One thing that is a little bit inefficient is that the pocket toolpath had to ramp down in, just like the adaptive one did. If I show the entire toolpath here for operation, that big long red ramping, right? So the adaptive toolpath did that, and then the pocket toolpath did that as well. But the adaptive toolpath removed a bunch of material already, right? So you don't actually need to ramp down that much. So we can change that in heights, and it'll just save a little bit of time. Not a lot, but a little bit. So let's do that. So I'm going to exit simulation, and I'm going to go to the pocket toolpath right there. I'm going to right click and edit. And in the heights tab, right? So bottom height is selected contour, so that's going to be that contour right there. But the top height is not actually going to be at the top of the stock right here anymore, right? It's actually going to be, we can say the top height is relative to the selected or we can say selection, either one of these. Selection, and I could select this surface, but it's not actually at that surface because I left a little bit of material on there. So we could go to this offset and say 0.02, which is the amount of material we left. So what I'm saying is that the new top surface is 0.02 off of this face. So right before this toolpath happens, this is the case. So go ahead and click OK. And I can see that that ramp just kind of decreased. It still ramps, which it has to because there's still material down there, but it doesn't need to ramp all the way from the top. So that's kind of a way of using heights to make your toolpaths more efficient. The other thing I realized is that in the adaptive right here, we didn't change the optimal load. So let's go back to that one. So if we edit the adaptive tool, the second adaptive toolpath with the 1/4 inch tool, we go to the passes tool tab. We can see the optimal load is 0.0625. If I check in the appendix, you can see that optimal load for 1/4 inch tool in aluminum is 0.067. 0.067. Close. 0.067. Okay. You can, I believe, say save as user default. Let's try that. I'm not sure how it'll affect the other toolpaths, but you can always check it in the book. Okay, 0.067 and okay. Okay, let's simulate that all again and make sure it looks good. So right click setup one and simulate. I'm gonna skip to the second to the adaptive here. Okay. machining into material. And notice that toolpath went down. So I'm actually going to pause this. This is a nice thing to do in the simulation environment, is you can, once it's paused, if you click and drag left, it goes in reverse. And if you click and drag right, it goes forward. So we see our tool kind of plunged down here. And then started the ramp right there. And then cleaned up the inside of that. Looks good. Okay, so next thing to do is to machine this area over here on the right. And what we're going to do is we're going to drill a hole. But in order to drill a hole on the CNC machine, it's going to be a two-part process. You first have to make a spot drill, and then you drill it out with the final drill. And then we can machine the area above the hole. So let's exit the simulation. Let's take a look at the diameter of that hole. We'll click inspect, and that hole down there is 0.25. That's a 1/4 inch hole. We'll be using a 1/4 inch diameter drill bit. Okay, so go ahead and close that. So we're gonna make our first drilling toolpath, and the spot drill is gonna be used first to make a mark for then the drill bit to actually find. It's gonna make like a divot in the top. The drill bit can actually find it, and it'll kind of make the position of that drill bit much more accurate. But a spot drill can't go very deep, but it is a more rigid tool. So let's go to drilling and drill. Okay, so it's not going to be tool number 3. It's going to be a different tool. So for tool, click select, go to CNC Beginner, and we are going to, so it says tool hidden by search filters because it's already saying hole making. It's only going to show us hole making tools. But I'm going to clear the search filter so I can see all my tools, because you can drill a spot drill with a chamfer mill, which is what we have in here. If I didn't have that, I'd have to have a center drill or a spot drill specifically, and I could put that in the library, but our chamfer mill will work just fine. So we can override that filter, and we can use this tool for this. So it's going to be 1/2 inch 45-degree chamfer mill. Click select. Okay, and we want to make just a spot in the material just above this right here. We can see that our toolpath dialog box for drilling looks similar to milling, but it's a little different. Our tool selected, the geometry, we can either select points or faces, things like that. I'm going to just select the face of this cylinder right here. And let's see, if you had multiple holes that were the same diameter, you could click select same diameter and it would select all of the holes. It's quite nice. So I selected the geometry. Now in the heights tab, I can see where this thing is going to be drilled. Okay. And if I look at this from the side, I can see, and actually I'm going to change this. This is kind of a nice way to do this. Go to my display settings, say visual style, wireframe. So I can see the kind of all the inside geometry, right? So this, since I selected that cylinder, it's going to think that the top of the hole is the top of the cylinder and the bottom hole is the bottom of the cylinder, but this is just a spot drill. I don't need to go this deep. And in fact, it's inefficient to go this deep. So, and sometimes it might actually get in the way of your, affect some of the other geometry for final parts. So we need to kind of be able to adjust this. And we do that in the heights tab. So I'm going to say right here, and really it's the top height and the bottom height that you're adjusting and you're playing with. Top height is the hole top. That's good. I want it to start the drilling at the top of the hole. Bottom height, I want it to be relative to the hole top, actually, because I want to control how deep it goes. So I can offset it a negative number. And the amount that it's going to be is going to be half of the diameter of the hole that you're going to be drilling. So this is a 1/4 inch, and that's the spot drill rule. It's that how deep does the spot drill go? Well, the spot drill should go half of the diameter of the hole that you're going to drill, if it's a 90-degree, it has a 90-degree tip on it, which this one does. So the hole that we're going to drill is a 1/4 inch. So half of that is 1/8 of an inch. So I'm going to say -0.125. And then the tip of that chamfer mill is only going to go down 1/8 of an inch into the material, and then it'll retract. Okay. So that has made our spot. We don't need to go to the bottom like it was, but really this is how you kind of adjust a lot of or how you do a lot of your work with holes and drilling holes, is kind of like adjusting the top starting point and the bottom starting point by changing the from reference point and the offset amount. The other thing to check in the drilling operations is the cycle tab. It looks like this passes tab, but it's a cycle tab for drilling. And then if you click on this drop-down menu, these are all the different types of drilling operations that you can program in Fusion. There's, drilling with chip breaking, deep drilling, tapping, left tapping, right tapping, reaming, boring, all that kind of stuff. Any kind of like Z focused movement drilling type operations. So we're just going to do drilling rapid out, which basically means that the tool positions itself and it goes all the way down to the bottom of the hole, and then it comes out in one movement. That's okay for like shallow holes and things like that. Once you get to deep holes, you have to worry about chip compaction down in there, and then we would do something like deep drilling, full retract. Yeah. But for this one, drilling rapid out is fine. Okay, and linking, we can leave those there as well. So go ahead and click OK. And there it is. Let's right click on setup one and simulate. And I'm going to skip down to pocket, start from there. And there's our spot drill. Cool. The reason we want a spot drill first is if we were to start with the drill bit, the very tip of the drill bit isn't very good at cutting. And when it first touches the top surface of the material, it can kind of walk around for like a microsecond. And it can kind of wobble. And if it engages in the material any place that's not directly below the spindle, it'll actually drill a hole at a slight angle. So really, to get this hole perfectly straight up and down, we first spot drill, and then we drill. So I'm going to exit the simulation, and I go back to drilling, and I'm not going to duplicate that one. I'm just going to make a new one. Drilling and drill. Okay. This time we are going to use a 1/4 inch drill bit, and we're going to drill that hole out. So I'm going to go to, for tool, click select. Now if you go to CNC Beginner library, clear search filters, there are no drill bits in here, right? And the reason for that is that, there's a lot of different sizes of drill bits, and it would make this library very large if you had all of your drill bits in here. And I've found that the Fusion sample library for drill bits is really good. So we're just going to use that. So I'm going to go to the Fusion library, and I'm going to go down to hole making tools inch. And it starts out with very, very tiny drill bits. So you'll see that on the side here, very tiny drill bits. And it has kind of like all the drill bits in here. So I'm going to go down until I see, it also has taps and things like that, and center drills and things. 0.25, 1/4 inch. Let's see, let's go over here. 1/4 inch, 118 degree drill bit. And on the preset, I'm going to select aluminum drilling, and then click select. Okay. So these presets, I think, work pretty well. It'll depend on your machine, and you may need to change some of these a little bit if it's too aggressive or it's not aggressive enough. But we're going to use the defaults for now. For geometry, I'm going to select this lower cylinder right here. And I'm going to turn my, oh no, we can leave that. We can leave it wireframe, that's fine. Okay, so select that geometry there, and then let's go to the heights tab. Okay, so a couple things here. One, it is starting the drilling at the top of that whole cylinder that I selected and ending it at the bottom, which is not exactly what I want. So what I really want is for it to start the hole at a different place. I want it to start it up here on this top surface. So from top height, I'm going to change that to from selection, and I'm going to select this top surface right here. And so you could see that the shaded blue area is where the drilling is going to happen, so it changed. The other thing is that even though it's drilling to the bottom of that hole, that drill bit has a tip angle on it, so it's not actually really drilling through. I want it to drill through because it's a through hole. So the stopping point, or the reference point is fine, but what I want to do here is say there's a check mark to drill tip through bottom, and it drills the bottom of the drill through the bottom of the part. But I want to go a little bit further, because even if you go right to the edge here, you're not going to have a clean edge on the bottom of your part. So I'm going to add what's known as a breakthrough depth, just a small amount, 0.02, and it bumps it down just a little more just so we get a really clean edge on that hole. Okay, there we go. Okay, the cycle type. Let's leave it as drilling rapid out right now, and let's see if we need to change it. So drilling rapid out again is just, it'll move over the top here, it'll go down and then come straight out. If it were a deep hole, we would have to do it, do what's called peck drilling, where it drills a little bit and then it pulls the drill bit out. Drills a little bit deeper, pulls a little bit out. Drills a little bit deeper, pulls all the way out. And it does that to clear chips away from the part, or to clear chips out of the hole so they don't get stuck in there. Okay, let's click OK. And before we simulate, I'm going to change this display settings, visual style, shaded with visible edges only. I'm going to measure here the distance from here, which is the top of the hole, to the distance to there, 1/2 inch. So a good starting point rule for is your hole a deep hole and does it need a deep drilling operation is the depth greater than 3 times the diameter of the hole. So our depth is 1/2 inch. Our diameter of this hole is 1/4 inch. So our depth is twice the diameter. So that's less than 3. If the depth was more than 3/4 inch, more than 0.75, then we would have to do a deep drilling, kind of pecking drill cycle type. But this should be fine. Okay, let's simulate the whole thing. I'm just going to skip down here to the bottom, and we got spot drill and then our final drill. And we can see that kind of go again. So we have final drill, goes through the bottom, and then comes up. Perfect. Okay. So we are getting close here to being done. I think we have maybe a couple more operations. So we have to remove the material from the top of this hole, and that is what's known as a counterbore. It's like a hole with a flat bottom. So let's, it's above another hole. So let's exit the simulation. So how do we do counterbore? Well, there is an operation for boring. So let's do 2D bore. For tool, let's try our 1/2 inch end mill. See if that's big enough, or if that's small enough, really. So we're going to use a tool that we've already used in the program. So instead of going back to the CNC Beginner's Guide tool library, we should select it from the document folder here. So at the very top is a list of all the open documents you have in Fusion and the different setups in those documents, and then the tools that you've added to that program. We can see that the tools actually have been numbered here, starting from 1 as we added them. in the order that we added them in. So looks like our second tool here was our flat end mill, 1/2 inch flat end mill. So let's select it from there, not from beginner's guide, because it might add another tool here, call it tool number 5, but it will still be our 1/2 inch end mill. We want to just have one instance of each tool in this list. We want the list to be very specific and very clean. So I'd go ahead and click select. And then for geometry, select the face of the bore. So this geometry right there. And there it is. Creates a helical toolpath that makes a cylindrical pocket with a flat bottom. So it's like how you make a hole with an end mill. If you add more holes of the same diameter, you could say select same diameter. Heights, I don't think we need to change anything in the heights here. And passes, I think that we should be okay there. Okay, you could do things like multiple passes, finishing passes, things like that, but I think that for this, this will be fine. So go ahead and click OK. And let's simulate. Right click setup 1 and simulate. Okay, I'm going to skip to the bore at the end and play it. There it is. Okay. So we just have a few left. We just have to remove this material from the outside of this part. And then we're going to add some little chamfers. We're going to break these edges. All these 90-degree edges up here, we're going to break those with a little chamfer. So click exit simulation. First thing we're going to do is remove material from the outside. Okay, and the way we're going to do that is with 2D adaptive, actually. So let's go to 2D, 2D adaptive clearing. And I think that we are going to use our 1/2 inch flat end mill because it's already in the machine, and it should do a very good job of this. If it's long enough, it should be. We'll see in the simulation. For geometry, we're going to select this lower outer contour. And we can see that it's shaded the area on the outside blue. And on the inside it doesn't have any shading. If for some reason, this is correct, this is what we want. But if for some reason it assumed you're trying to machine on the side that you're actually trying to machine on the other side of, you can click this little red arrow and it'll flip the side of that line that you chose. But we're going to flip it back so that it's on the outside of that line. Okay. Under heights, and this one's important. We want to actually go a little bit lower than the bottom of the part. And this is, with the expectation that you might flip this thing over and clear off the bottom of it. Because just like with the hole, you don't want to drill a hole right to the edge. You want to go a little bit further so you get a good clean bottom edge when you clean it off. So for the bottom height, we're going to give it a negative offset, a negative 0.02, just a little bit further. So that means instead of the tool going down to this point of the contour, it's going to go a little bit lower than that to do the machining. And under the passes tab, make sure stock to leave is checked because this is just a roughing pass. We're going to come back with a finishing pass. And click OK. One thing we didn't check was the optimal load. So I'm going to see what we added for the optimal load up here. I'm going to double click or right click edit that toolpath. And under the passes tab for the 1/2 inch tool, optimal load is 0.1348. Cancel that. And I'm just going to open this one up again and make sure we're at the same. Nope, it's not. To load 0.1348. And OK. There we go. So it looks like it's actually just once around because, that optimal load allows you to get to the final surface pretty quickly. So let's right click setup 1 and simulate. skip to the adaptive and play. Now I can see, I'm going to pause this thing right here. I can see it looks like we have clearance. So our tool holder is not going to hit our part, but it's close. And this is only going to work on the actual machine if the tool, the length below holder, the amount that the tool is sticking out of the holder is exactly the same or greater than the value that it is in here. And you have to go back into the tool library to see what that value is. But your tool should match, your physical tool should match your digital tool, and your simulation is only as good or accurate as that that model is. So go ahead and click play, and that looks pretty good. So even though that's kind of close, it's still good. Okay, exit simulation, and now we're going to do our finish pass around the outside, and that's going to be, we're going to do that, we're going to create a derived operation, because same tool, same geometry, same everything except for different kind of pass. So I'm going to right click adaptive 3, create derived operation, 2D milling, and this is going to be a 2D contour. So a 2D adaptive or a 2D pocket clears an area of material. 2D contour just traces a line. So this tool is just going to go down and it's going to trace the line that we selected. Because we did a derived operation, it's the same tool, it's the same geometry, and we just need to go to passes and make sure stock to leave is unchecked, and it is unchecked. So it should machine down to the final surface. You can make, we're not going to go over all of these settings in here because it would make this video, 20 hours long. But, you can try to make changes in here if you want, and then see what happens, right? Try and figure out what this setting does exactly. If it's what you want it, if that's something you would want, you can make changes here. And then the simulation is a really great place to see how the changes you make show up in the actual program, because it shows you visually right there what's going to happen. Like visually confirming it is probably the best way to do it. The linking tab, let's see. We can, let's simulate first, and let's maybe change something in the linking tab just for practice. So go and click OK. And we see it just kind of simply traces around it. So I'm going to right click setup one and simulate just to make sure that that adaptive looks good. And the contour to finish it up looks good. We can see it's going below the bottom of the part by 20 thou. Okay. Yeah, that looks good. One thing is right here, it's entering this material here and it's exiting it right on this face. And I found that actually, even though these machines are very precise, very accurate, a lot of times when you're entering or exiting adjacent to a big flat face, you'll leave a mark with your tool. It'll be like, you almost see it more than you can feel it. But it'll be there. So one way to change that, if we go to the contour and we edit it, if we go to the linking tab, so linking is all about lead-ins and lead-outs and transitions. So what I can do here is I can say, you can change a lot of that, the details of that stuff. You can change the radius of the lead-in, the sweep angle, things like that. You can also change the positions that it enters and exits. So pendrel position, location, pre-drill positions, something else. But you can specify where you want it to enter and where you want it to exit. So yeah, here it is, preferred lead-in position. So I could say sometimes on an edge is good, and then you can have it exit at the same point or at a different point. And click OK. And I can see now that that entry and exit point actually changed to right over there. Some positions are unusable. Oh, okay, so we got a warning here that says some exit positions are unusable. So let's go back in and let's change that. Something must have happened, maybe selecting the same point. So go to the linking tab. I'm going to exit both of these things here. I'm going to say maybe the preferred lead-in position is right here. Or lead-in position, let's see, we'll make the exit position this one. Nope, I'm going to turn both of those off. Okay, lead-in position should be maybe this one, and exit position maybe this one. I don't really, I don't know exactly what's going to happen, but this is like, there's just so many settings, there's so many different things. When you're doing CAM programming, this is what it looks like. You try something, you go ahead, you simulate it, and you see what happens. It says some exit positions are unusable still, so I'm going to go back in. And this is really like the kind of nuts and bolts of programming. It's like you try something and then you see what happens. So I'm going to say, I'm just going to give it, in this case, a lead-in position here and see what happens. And that looks good. It actually made the exit position at the same point as the lead-in position, so I didn't need to select it again. Yeah, but like I got there eventually from trying a couple different things. Like that's how you're going to get really good at this kind of stuff, is you're going to try a bunch of things, you're going to simulate it, you're going to see what it happens and how it looks. Okay, so let's simulate that one more time. And that looks pretty good. All right, so the last thing for us to do here is to add some chamfers. Okay, so let's exit the simulation. And let's do this. 2D chamfer. And a chamfer is basically taking a sharp 90-degree edge, and I know 90 degrees doesn't necessarily always mean sharp, but when it's a machined part and you've machined the top and you've machined the side, you oftentimes have a burr of very sharp material left along that edge and these edges, and they can even cut you. Like, they're very sharp, they can be. So we're going to make a chamfer on all those edges, and then we'll hopefully do what's called breaking the edge, kind of breaking the chamfer a little bit. So 2D chamfer toolpath. You can also make chamfers with contour toolpaths and trace toolpaths. But we're going to do ours this time with a 2D chamfer toolpath. For tool, click select, and we're going to select a tool we've already selected before. So we're going to select it from our document file here. So tool number 4, the 1/2-inch chamfer mill, and select. And for geometry, we want, see, this line here, these top 2 lines, and this line here. And don't need to change the heights, but for the passes, we have these 3 values here: chamfer width, chamfer tip offset, and chamfer clearance. I go into much more detail into what these things mean in the book, but for now we can set the chamfer width, which is like the physical size of the chamfer, to something really small, 0.005 thou. Chamfer tip offset can be, 0.04 is good. That's kind of how far the tips sticks down below the edge to make the chamfer. And let's click OK, and let's see what happens. Okay, so it looks like let's see what the simulation looks like. Again, go down to the chamfer here and click play. There's a chamfer, and if I kind of pause it here and I look at it from the side, I can see what it's actually doing. It's removing that, just a little bit of that edge. And so the chamfer width is this size of this right here, and then the chamfer tip offset is a distance below that the tip of the tool sticks down to. So it's just making its way around. And then was the hole there at the bottom. Great. And then it tries to do this outside perimeter, but it can't get very far because it gets close to this edge here. And if it were to actually machine that, the tool up here would hit this part of the part. Right? You can see that it's actually would interfere with it. So how do we get a chamfer on that? There is a way, and I think that the way is going to be increasing the chamfer tip offset, but just for that. So have the tip stick way down here. It's going to move the edge of the tool over as well. It'll only work for this bottom one, because if you were to try to do it up here, you might the tool might be too big, or you might actually get some collisions, other collisions with different parts of the part. Okay, so here's what we're going to do. I'm going to exit simulation. I'm going to go back into this chamfer. I'm going to go to geometry. I'm going to deselect this one right here. So I'm going to click on it, and actually no, cancel that. I'm going to click on these until I see it highlighted. It looks like it's chain 1. So I can click on it. Chain where I see it kind of like highlights a little bit when I click on it. I can click the X to remove the geometry from the selection. Okay, so the first one's just going to machine those ones right there. And then I'll do another chamfer toolpath. So we could just say 2D chamfer. Same tool, it's already selected it because it's the previous tool. It puts it in there automatically. Under geometry, you could say just this outer edge here. And then under passes, chamfer width, same as before, 0.005. Chamfer tip offset, let's try 0.3, like a really big one. And let's see what happens. I'll click OK. See if it actually, that might actually be too much. So let's simulate that one. Right click and simulate. Yep, way too far. So I need to decrease that. So maybe something like 0.2. This is going to be a little bit tricky. Also, I want to check on one thing here. I want to see the distance between here and here. 0.075. Okay. I'll go to that chamfer again. I change this chamfer tip offset to 0.2. And I'm going to change the chamfer clearance, which is basically the distance, how close it can get to any adjacent faces before it moves away. So if I make that smaller, it can get closer. So I'm going to say 0.005 for that one as well. Okay, let's simulate that and let's see what happens. Yeah, that might be it. So let's take a look at this from the side. All right, so it looked like that was actually a great combination. 0.2 chamfer tip offset, 0.005 chamfer width, and 5 thou chamfer clearance. Let this tool get the cutting edge on that 90-degree edge all the way around without hitting any of the other parts. Okay, so that is it for all the toolpaths for this part. I know it's a lot. It's a very simple part, and the programming kind of took a while. But, you know, once this has been verified on the machine can run this part, you know, thousands and thousands of times. And it'll be very, 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 very accurate. So that is it for the toolpaths for Project 1. The next step is going to be, how do you make these toolpaths into G-code for the machine to run? And that's called post-processing. In the next video, we're going to post-process these toolpaths, and we are also going to create setup sheets. And that's for the machinist. And it's going to have all the details on this program, things that the machinist needs to know when they're at the machine. So we're not quite done yet, but we are getting close. And I will see you in the next video for post-processing, the part 3 video for Project 1 CAM. See you there.